Hello, hi. We're going to go through the SAS program and a couple things I wanted to talk about. Okay. That sometimes you can figure out the code is, you can memorize the code, or you can have SAS create some of the code for you. So in this exercise, hopefully you'll have updated, let's see, I saved this code. Hopefully you'll have updated where you have the red cat data Excel file within or saved within your folder. And what I'm going to do, if you right click the red cat data, it'll ask you to import data, and you'll have this thing right here, and it'll give you this thing right here, the red cat. What you can do is you can steal some of this code in here. This gives you, based on mine, where it's the file name ref, and then it has the directory, which said it'll be different on yours depending on what your account is. That's what I want to, that's the most important thing I want to save. If I copy this part into my program, I'll have it. And then I've created this file. I added a bunch of annotation to it, a bunch of comments. And so I have the file name on row 5, and yours will be different depending on how your account is. I have some other things in here. I did a little bit of modification, but let me explain each of the parts. You look at the import procedure. There's some things that are really important. Some things are not as important. What's important, we're using the database management system XLS X. That's newer version of Excel. If you have the older version of Excel, it's XLS. If you're importing a CSV file, right here is where you designate that it's a CSV. You might do a couple of things a little bit different, but that's how you would designate the type of a file that you're importing. You can import any type of data or most types of data. It's good programming practice to include the replace statement. You don't have to. If you're only going to import something one time, that's fine. There's out, and you don't have to say work. If you don't put work, you'll automatically put it into the work folder. Maybe there's a different directory where you want to put things in, but work is your sandbox. And so I just put it there explicitly. I'm creating, and I updated this part from what was given to me to a customer, because for at least this import procedure, I'm going to be creating for the customer table. And it's kind of hard to see with this online program, but if you use a desktop version of SAS, all of your tables are to the left. And so having a naming convention that lends itself to finding the data really easy can be useful, which is why when I write my programs, I put all of the names in sequential order. And I use alphabetically a letter and underscore that gives me up to 26 different options, which is usually more than enough to categories of naming names to use. That's why I have my names. That's why you can call yours whatever you want, but use something that makes sense. Get names that is by default has a yes, and what that means is when you're importing from Excel, it will use the first row to populate the names, the attribute names, or the column names. And because I'm pulling this in from Excel, from a workbook that has multiple worksheets in it, I can explicitly specify which sheet I'm pulling from to create this table. That's where the sheet equals. And so this will give me, if I run this, I can select just the code I want to run, select it, and I can hit either F3, or I can come up here and hit this little running man, and that will run all of this. So I'll run that. I can check the log. The log says, okay, I pulled it in, gave me some information, how long it took to run it, page default. So it gave me how much memory it took, what it gave. So it was that 4,800 input operations. I can look at the results. I don't see anything in there. Output data. There's there's some information about what we just imported into SAS. And this only has one table, work customer, within that set of code. Looks like I can close that now. And so I'm going to go back to the code and take a look at it. So I use this file name thing, which kind of assigns a shortcut to this. I don't have to use that. I can, now that I have this information, I can just put that within here. So if you're using SAS, you want to specify where you have that. Actually, anytime now that you have something saved within this thing right here, you can use this designation as to specify what where to get the data. And so the most important thing I have here is proc import data file. I have the type of file that it is, replace, and I have out. And really, once you put this thing right here, and let me clear that. Once you have the proc import, once you have that part of the statement and that part, all these things that you put in, you can put in any order you want, and it doesn't matter. I put out equals near the end. That way I can copy and paste the code, and then I know where to go. I don't have to kind of hunt in the middle of the line. But put something in there that makes sense to you. And it goes from the sheet sale. And so once I have that, I can take this code, I can copy it and paste it. And actually what I did right here, I just had that file name ref file, just as a shortcut. And then once I have this, I can copy this and paste it, and I can get the inventory item table in there. I'm going to update for the next assignment, the next exercises we do. I'm going to add some more of those data sets. We'll update the Redcat 1 Excel file. And so you'll want to add some more import things so you can practice pulling in data. Okay, now that we pulled the data into our sandbox, the next thing I'll do, so I'll just run these. Make sure we have them, the little running man, or F3 key will give you the same thing. Okay, we've got these tables, customer inventory item, sale item. And oh yeah, let me pull up the schema. We can figure out, we have these 4 tables. And from here, we can figure out what we're going to do. It looks like the foreign key between customer and sale is this customer ID. So that's where we want to merge something. It looks like when we want to, or join, if you want to join sale and sale item, we'll do this. That's our foreign key. And so this diagram, if you don't have one of these diagrams, it will be convenient to draw it out, either map it out, or the one with the visuals like this, or the one with drawing out, so that you'll know how to be able to, what you need to merge in order to create the tables that you want to do. Okay, close this out. So let's go back to SAS. We've got all of this stuff. So now, we need to merge the customer and the sales table. To do that, in SQL, when you merge tables, you can simply merge them, and you can join them. You don't have to sort them. But in SAS, and actually in many programming languages, you'll want to sort them first by whatever variable you're going to be merging. And so if we want to do this, we finish this by, oh, I guess I did have that already. So we have the sort procedure. We're going to be sorting the A sale table, and we'll sort it by customer ID variable, then run. So any procedure you have will start with proc and end with run. Everything in between is a procedure. The other thing that you do in SAS is a data step. A data step always starts with, oh, let's go down a little bit. Always starts with data and then ends with run, and everything you do in between. Those are the 2 main things we're doing. So here we're doing we're sorting this. We're sorting the sale table by customer ID. Then we sort a customer table by customer ID. Once they're both sorted, we can merge them together. And we'll merge them with a data step. There we go. And so data, and I'll just call it B, data A, so where it shows up next. we're going to merge a customer and a sale. And I added these are optional, but I added these in equals first and in equals second. And what that does is when we merge two tables together, you could think of here's a customer table and here's a sale table. When you merge them together, you have all of this stuff in here. If we tell it n equals, if you say, we have this line where it says if first, if second, what that is saying is only include all the records that have both this table and both that table. So you're excluding everything else, all the extra fluff, the records that are in one but not in the other, you're not going to include that. That's what that thing does. Drawings. So we merge these tables together. We tell it what the foreign key is that we're merging. You'll notice it says by customer ID, and really you can put as many attributes as you want, many variables as you want to merge them by, where that it'll join the tables together. Ooh. That you'll join the tables together. You could have whatever number of foreign keys in your join. And then the data step, you can also do, oh, sure, whatever. In the data step, let me copy this again. Whoa. Let's see, we were right here. In the data step, you can do other things. Like, for example, I did this keep because I noticed there were some additional variables that were not part. Let's see, hold on a second. There's some issue here. Share. Okay, hopefully this is working now. Because you'll notice this has there's some additional variables outside of what's in the schema. And so that the schema is probably not the most accurate thing that we have, but I wanted to kind of keep it true to that. And so I did the keep. Keep means you're only going to retain these columns. And so I did these ones that we will want from the customer and these ones that we will want from the sale table, the sale objects or tables. And so when we run that, we can look at the output data. We want to look at B data A. So B data A. So we have this table that's customer ID, city, state, sale ID, the sale date, or whatever. Now we can, let's merge in the sale item. So if we look at our schema, we have this join already made. Now we want to make this join. So from the sale and the sale item, we'll merge them. We'll join them by the sale ID variable. Let me get this out of here. Okay, so now we'll sort. We'll sort both of these tables and then we'll do the merge. Clear all drawings. Okay. And so I'm going to hit that, hit F3 or hit the little running man. And we have now B data. Oh, let's see. B data B, that's what we want. And we've got all this information about sales. It also includes item size, quantity, sale price. And then we created a variable called revenue. Revenue is quantity and price. If you're selling so many items at specific prices, the amount of revenue that you pull in is a simple mathematical operation of multiplying those two together. And I formatted the variable. If I don't format it, it'll just be some funny number thing. So I gave it this nice little format. It'll make it look pretty. Revenue. So let's take a look at that. We have revenue. Looks like money, and that looks a lot better than what we have for sale price. And so there's that column. And now we can start doing some aggregations on here. One that we might want to use, you can use the proc summary, the summary procedure to do the mathematical operations. You can also simply use it to start to roll things together to condense your data. There, there's a really complicated process to condense data uh, that, I mean, one of my places where I work, they used to use, but really, I think the summary procedure is a much easier way to do it. Let me walk through how I used it, the summary procedure. I put some literature in Canvas. If you want to read about this. The proc summary data, this is data equals B, and the table that you're going to be rolling together or doing whatever analysis you're on. That's a data equals. Anyway, what happens is when we're using something called a class option in here. And the class says all the variables that we're using to roll together. And if you don't have Nway, proc summary will give you every single combination of those variables. In fact, you know what? Let's do this. I'm going to comment that out, at least temporarily, and we'll run this without it, and we'll see what happens. But you have this class. These are all the variables you're going to consider rolling together. And I told it to drop, you know what? I'm going to hide this part too, because they give you two additional variables when you run the summary procedure. That's called type and freak. And I'll show you what those are in just a minute. So you have output out. You specify the table you're going to create. And then after you put output out, before you put a semicolon, you could indicate whatever type of a mathematical operation you're going to do. And you can look it up to figure out which ones they are. But another little trick you can do, you can use your log to help you program. If you want to know all of the potential mathematical operations you can do, you can write some bad code. And so I'm going to do summa. That's not anything. You notice it's not blue anymore. So when I run that, let's take a look at the log. Oh, it did something. Oh, it assumed the symbol sum was missed. Okay. So we need to make it pretty obvious. Submarine. That's not an operation you can do. Maybe it'll make, oh, there we go. And so now if we look at the code, expecting one of the following: CSS, CV, ID group, ID kurtosis, CL. These are median, min mode, N is the count, and miss out, P1, P10, P20. So we have these different percentiles. We have probit, Q quartiles, Q range, skewness, standard deviation. So we've got a weighted sum. We've got all these different types of or variants. You've got all these types of mathematical operations that you have at your disposal to use. So if you want to figure out where it is, break it on purpose, check out your log. Your log can give you some hints there. Let me put this back to some. And we'll run this without the Nway option. And okay, I'm going to select this. F3, I'll click on that. And let's take a look at this. Frequency is how often it appeared. So when we summed the entire table, let's see, we were summing B data B. There were 12,569 observations in here, or that many tuples. And so we're not considering any variables. The customer ID, state, and city, they're all null. There's total revenue. All the sales is that amount, about $750,000. Now we look at type 1. What is type 1? You notice there's nothing about customer ID, nothing about state. All it has is each city. And so you have type 1, you have the frequency is how many. So if you look at all of the Abilenes, there are 6 Abilene, there's 1 Aberdeen. Did I get that right? 7 Abingdon, 6 Abington, and so on, and the total revenue. And the tricky part about this, though, is that if you have 2 cities that are in different states, but they have the same name, it will add them together. It just looks at the variable city. So frequency 1 is everything for just city. If you go to frequency 2, it will probably be just state. Frequency 3, just customer ID. And then you have a combination of customer ID state, combination of customer ID city, combination of state city, and on and on and on and on. And so that, I mean, that could be useful in some applications, but I find it easier just to do anyway. And let's see what happens if I take this off. I told it to drop the type and frequency variables that it automatically generates. And so when I run this, now you'll notice that type and frequency is no longer there. If I didn't drop frequent type, you might say 7 or whatever number that is. But now, because I have N-way, it gives us the maximum combination of customer ID, state, and city. That's what we had the class in. And the only thing we did is calculated is the total revenue. We could have summed more things further and further out, depending on how many variables we wanted to put. That's good enough. Okay, so now we have all of the what this table shows us is this customer ID 12, who is from Portsmouth, Virginia, spent about $350. This person from Kincaid, West Virginia, and Road 9 spent almost $400, and on and on. Now we have it aggregated by customer and the amount of money that they spent. We can do some calculations that we're looking for. And so what I'm going to do right here is I'll take that table, I'll sum up all the revenue, and also do a count. But you'll notice the class only has city and state. And what this will tell me is every city and state combination, how many individuals there were, and how much money they spent. You'll notice I created this customer count using the N, but if I didn't drop the frequency, it really is the same thing. So you could make sure you have the frequency in there, and then you'll see what that count is. So we have sum total revenue. And then once we have that, we can limit this down to just the city we want to see. There were 3 cities in the first set of problems: Birmingham, Peoria, and Scottsdale. There's 2 Peorias. We wanted the Peoria in Arizona, not in Illinois. And so basically what I said here is if the city is the name, then we'll keep it. The next one says if city of Peoria and the state equals Illinois, then delete that row. And we do that, and we have just the table that we need. So the towns that we want, total revenue, customer count, and we can use that to answer the questions. Okay, that's great. That's for the first part. That's one way to do it. Actually, so before we look at the second part, let's look at another way to do it. If we go back to B, data B, we can roll things together by looking at the customer ID. And so what I did is I created this table called C data score D1 set B data B. If city equals those 3, I use the same criteria I did before. So by running this, we have it limited to just the customer ID, city, and state. And I guess what I could have done is I could have kept, let's see, what is that revenue? Is that one is, I wanted to sum that. Yeah, let's keep revenue. Then we can do a proc sort, node up. Well, actually, we don't want to undo the duplicates. Actually, we probably wouldn't even want to do this. Let's see. We don't need to, if you want to include the revenue, then you don't want to do the sort and get rid of this. This was, actually, I'll just go back to what I was doing here. So we have customer ID, city, state. You can unduplicate that list. And the log tells us we had 93 duplicate observations were deleted out of 111. That means we have 18 observations. It's because some of the customers had more than one transaction. And so we got rid of the duplicates. Now we can just do a simple summary, and we can see the counts by each of these, the frequency for each of these towns. So that's another way to answer at least part of that question. Let's look at what happened. How do we summarize the product sold? We can actually write a little bit more of an elegant proc summary statement. And I'll show you how we can do that. If we go back to the B data B, which I need to run this again so we can take a look at what's in here. B data B is a pretty nice table because it has really all the information we need to answer every single question that we have. We have the customer ID, the city, state. We have something about the revenue that happens, the number of transactions that happen. So it's great. If we look at this, so what I did is compute the count of products sold by city and state. And so we're using the summary procedure, class, city and state, and then we're output out equals C data E, and we're summing the quantity of products. Now I did add after the output out, within the parentheses, you can put all the options you want. So we have the drop, the type, and the frequency variables like we did before, but I added a where statement. And with your experience in programming in SQL, I think you'll this use the same intuition you used for SQL. So what I said is where equals, and then here we have city of Abilene and Atlanta. Those are the two ones that we need for the questions that get asked at the end of this quiz. And so we run this piece of code, and this tells us that in Atlanta, Georgia, there were 79 products sold. In Abilene, Texas, there were 6 products sold. If we didn't have this where statement right here, I'll comment it out. This will give us every single city and state and the number of products that were sold. So I can make this, so we can read it. So Edmonton, Alberta, 1, Innisfail, Alberta, 6, and on and on. There's 1775 total rows, different tuples of this that so a lot more information than we need, but included in here is what we needed, which is why I qualified it with this where statement, just to make it a little bit easier. All right, now I'm going to save this code on Canvas, and I'll put it in Canvas. And what I would encourage you to do is maybe if you're this would be a good thing to play with the code and make some adjustments. Make sure you understand it. I'm going to be putting together a homework problem pretty soon, and you'll want to use some of the code that we have in here, either replicate it or duplicate it, or copy it and modify it so it fits your need. Let me know if you have any questions about what I did with this video, and I'll be happy to share. Thanks.